talk about the linearization of partial differential equation, and in the previous video you saw that we reached at the equation perturb equation. So what we do now, we have to compute the Jacobian matrix first, and we know that the Jacobian matrix is partial f vector by partial q vector, that will be equal to partial f1 partial f, maybe I should write like this: partial f1 by partial q1, partial f1 by partial q2, and then we have partial f2 by partial q1 and partial f2 by partial q2. And we remember that what is f1 and f2. Maybe I write f1 and f2 here again. For example, for vector f, we had f1 rho u, and then we had rho u square and pressure P, which is a function of rho. And when we write this in the form of q, which is q2, the second variable, and here we have q2 square divided by q1 plus p q1. This is q1. So that was f. Now we want to take a derivative of this f1 and this f2 with respect to q1, q2, then f2 with respect to q1 and q2 again. So first we write partial f by partial q vector, that will be equal to, when we have this f1 and the f1 derivative with respect to q1. So this q1 is not q tilde. Okay, remember that this is not q tilde, as we know that we have to first find the Jacobian, and after finding the Jacobian we put the value q naught vector. So the Jacobian will be, the first value will be 0. Here we have 0. What is the reason why there is 0? Partial f1 by partial q1, since this f1 and the q1 is density, and the derivative of q1 f1 with respect to q1 is 0. And when we have partial f1 by partial q2, partial f1 by partial q2, and what is f1? F1 is partial the derivative of first quantity with respect to q2. What is q2? Although this is rho u tilde, but we need rho u. So the derivative of rho u with respect to rho u will be equal to 1. So we get 1. Similarly, you calculate all the other derivatives. This is f2, and the derivative, or maybe since you are taking a derivative of f2 with respect to q1, you actually transform it in your f into the q. So that becomes minus you are taking a derivative of second quantity, this quantity, with respect to q1, and this is q1. Maybe I write this q vector to memorize it, q1 and q2, and you want to take a derivative of that. So that will be equal to minus q2 square divided by q1 square. Then we have the derivative of p dash, the derivative of p with respect to q1. Remember that. So we have dp by dq1, and we evaluate this at q1. And then we have partial f2. What is f2? f2 is this quantity. Uh, f2 is this quantity, and we take a derivative of that with respect to q2, with respect to q2. So that will become 2q2, since q1 is a constant, because we are taking derivative with respect to q2, plus, and this quantity will be 0. This will be 0. So what we get? We get partial, 2q2 divided by q1. That is the Jacobian matrix. We further simplify it in terms of u. We get 0, 1, and minus q2 square. Minus q2. What is q2? Rho u whole square divided by, what is q1? q1 is rho. This will be equal to minus rho square u square over rho, and there is there is a square as well. So we get minus u square. So we get minus u square over here, and I write it formally minus u square. And what is this quantity? This remains the same, plus p dash and q1. And the next quantity is how we identify what is that quantity. 2q2 over q1. What is q2? q2 is rho u. And what is q1? It is rho. Rho will be cancelled out, and you get 2u. So I put 2u over here, and I write it 2u, so on. So we finally have to put the vector q naught. Vector, what does it mean? What we have to put? We have to replace, wherever we have rho, we will replace this with rho naught, and wherever we have rho u, we will replace this with rho naught u naught, right? So we also need to change this variable as well. This becomes rho naught, since it is equal to q1. So finally we will get 0, 1. What is u? It becomes minus u naught square. Wherever we have, you can keep it like this. For example, you put q naught over here, minus q naught 2 whole square divided by q1 naught. Then you get minus u naught square. It is similar to that what we are doing over here. So minus u naught square plus P dash rho naught, and then we have 2u naught, and that is equal to 2u naught. Okay, so this is the Jacobian matrix, and we call this Jacobian matrix equal to A. So this become A. When I put this value into the perturbed form, we get, maybe I write this again, partial q tilde by partial t plus A partial q tilde by partial x is equal to 0. And what was A? We already have A over here. A is equal to 0, 1 minus u naught square plus p dash rho naught and 2u naught. We put the value of q tilde partial by partial t, that is equal to rho tilde, and this is equal to rho u tilde plus, and A is 0, 1 minus u naught square plus p dash rho naught, and we have 2u naught equal to, I'm sorry, there will be partial by partial x and rho tilde rho u tilde equal to 0. And the matrix form, I'm sorry, the scalar form will become partial, maybe I write over here, partial rho tilde by partial t plus partial by partial x partial by partial x rho u tilde is equal to 0 when you multiply the matrix with this term. So we get the second equation, partial by partial t. This is rho u tilde. So that becomes rho u tilde, rho u tilde plus minus u naught square plus p dash rho naught. Since we have to multiply this row with the column, so we get partial rho tilde by partial x, and the second quantity, when this second quantity multiply with the second one, we get 2 plus 2u naught partial by partial x rho u whole tilde is equal to 0. So this is the final form of the perturbed equation in component form. In the next step, what we do, we actually derive the acoustic equation out of that acoustic equation, out of these equations. Thank you for watching.